bisa berbincang-bincang sejenak. Mohon ditunggu, mohon pemaklumannya. Terima kasih. Baik, Bapak dan Ibu, izin kami mulai acara ya. Yang kami hormati Bapak Muktianto Suryowibowo, selaku narasumber pada sesi presentasi teknis kita pada siang hari ini, serta seluruh Bapak dan Ibu yang kami muliakan. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera untuk kita semua. Kami mengucapkan selamat datang kepada Bapak dan Ibu telah berkenan hadir mengenai presentasi teknis yang akan membawakan materi mengenai potensi wilayah kerja Bobara yang kemarin telah ditawarkan oleh Direktur Ditjen Migas melalui mekanisme penawaran lelang reguler dan akan ditawarkan selama 2 bulan durasi lelangnya. Wilayah kerja ini berada di lepas pantai Papua Barat, sebelumnya dikenal dengan Aru dan West Papua 4 yang telah diterminasi kontrak kerjasamanya. Dan telah hadir bersama kita narasumber sekaligus tim Capman yang mengevaluasi wilayah kerja ini, Bapak Suryowibowo. Untuk itu, pada Bapak Suryowibowo kami persilakan.
All right, good afternoon, everybody. Sorry, apologize for the delay. I was unaware that this is also put in the Zoom, so that I have to transfer the file into different computer. All right, so this afternoon, as mentioned, we are going to discuss around the Bobara area, which is part of the Aru project. So if you're aware that the last year is since actually 2021, we were assigned to evaluate 5 areas, which is the Buton here, Seram, and then Warim, and been presented by Professor Mino yesterday, and then Aru and Timor. So that was 5 area. So this is the Aru area, which covers this area here, and Bobara is sitting there. So next slide. So this is the Bobara block that was announced yesterday in the main conference room, been put into the regular tender in the area that was previously, you will see later that it was previously operated by Repsol there. So, you know, the study area is much bigger than this, so I will only focus for the area around the Bobara. Next. This is just to let you aware that the the study area coverage around 65,000 square kilometers, covering this area. And the way we do the analysis, the evaluation, we divide it into 5 sectors. So sector 1, sector 2, sector 3, sector 4, and sector 5. And therefore, throughout the presentation, you will hear that I will be using terminology of sectors. Just to be aware that this is sector 1, 2, 3, 4, 5, and Bobara is sitting here in a sector 3. Sector 3, and this is the Aru Island, just for reference. And this is the Aru Trough, and Bobara is sitting just on top of the Aru Trough. So if you look at on the this is the water depth. This is a shallow, and the darker color means deeper. And as you see, this is the deep area. Depth is in the order of 3,000 to 4,000 meters. Next slide. This the data set that we used during the evaluations. So a total of over 2,000 2D lines, or in kilometers is over 150,000 kilometers, with some 3D data included in the evaluation, such as in here, there, and there. So you will see that the Bobara area is actually has some 3D data. Yeah, some 3D data in here. So we also use the existing wells around the area. Total is what 61 wells that have been looked at to support the analysis. Next slide. So let's start with the regional geology. Next. So this is to give you a picture of the free air gravity. This is the dot line. Best line here is the area that we studied, and this is the Papua Island on to the north. And as you see that the Albany fields is in here, so inside the study area, and this is Timor Island, and this is the Banda Arc. So if you see the gravity data, you can see the continuity of the Australian continent. The extending to the north. So it is just the whole area is basically is the northern part of the Australian continent. And the deeper area here is representing a deep and or thick sedimentary, such as like in the Akimaga area here, where there is the central Papuan fault belt. So the area that you will see to the west northwest is bounded with the accretionary prism of the collision of the Australian continent with the Eurasian plate, that creating the outer Banda Arc. This is the deep area along the collisions, and to the north, the boundary is the collision between the Australian plate with the Pacific plate that generating the central Papuan fault belts. Next. Just to give you the a general picture, so that you will easier to imagine what the area that we studied looks like. So this is the 3 seismic section, regional seismic section, extending. Number 1 is from the northwest to southeast. Number 2 going to the middle, the north-south, and this is the section number 3. So if you look at on the, I'll start from the middle one, just to make it easier for you. That this is the this is the area that we look at. The colors, the horizons here is representing the major horizons that we mapped. Starting the old one is what we call as the Permo-Triassic boundaries. Yeah, so we are using as sequences, as major sequences that's been defined by the study did by Corlab and Pertamina back in 1992. So this is the oldest, is the Permo-Triassic. So we then evaluate the section below the Permo-Triassic, and I'll tell you later why that we didn't evaluate that one. And then number two is the dark green, which is here we correlate with the biostratigraphy is we call this Cretaceous. Actually, there is the another one, dark blue, but it doesn't appear in here. But however, that the what I want to show you here is the middle area is basically is a dome, if you will. It's a big platform, and to the south it thickens a little bit, and to the north it's thickened lots by the here. So you can see the sequences of sediments younger than the Permo-Triassic, and it does spins out to the platform. And if you go to the further to the east, and then what you see is again, this is the platform, and goes deeper, and this is the thicker area to the area where what we call as the foreland Akimega Basin. Akimega Basin is in here, so you can see the thickened area, thickened sediment, and then again it pins out to the main area or to the Arafura platform. And here, the one the most to the west of the area, you can see if the section goes from Troubadour 1 through the Abadi 1, well, Barakan and Koba, and also ASE 1. So it goes, you can see more variety in terms of the sediment thickness and the also the stratigraphy of the area, and it goes to here. This is what we call as Aru Trough. This is the Aru Trough. It's a very deep trough, which you know later I'll explain that this is a very young feature, which is only about 5 million years ago. Yes, it's very deep. Deep here is around the 3,000, 4,000 meters. And this is where the Bobara block is located. There's a very complex trough in here later that you can see in a more detailed seismic section. Next. So this is the another 4 regional section we looked at on the northwest, southwest, northeast regional section. Now we are looking at the section from west to east. Yeah. So again, I'll start with from the south, and this is the Abadi field. This is the platform, as I showed you before. So it does take a little bit to the east, but then this is along the shelf edge of the continent, Australian continent. You can see this kind of much thicker sediments, younger than the Permo-Triassic. Yeah, so this is the seabed, and this is the Permo-Triassic is in purple. And going to the north, this is the Barakan 1 well. Again, that this is the area of primarily the Aru platform. There is a thickening little bit as it goes to the Akimega area, or the foreland basins, and then to the west, this is the southern part of the Aru Trough. Start to see the thickening and also the deep water of the Aru Trough and some complex structures. And goes to the north, number 4. Again, this is the accretionary prism of the Banda Outer Arc, a big major bonding fault here, and this is about at the middle of the Aru Trough, and goes into these wells here, and then it you can see that the starting of the thickening above the Permo-Triassic section close to the Akimega Basin. And this is the most complex area. Here is the section number 7 that goes, toward the northern part of the study area. As you see, this is the Andalat 1, and then this is the accretionary prism, the outer Panda arc, and then goes to the Aru Trough, for the northern part, the part of the Aru Trough, and goes thinning out to the east of the Arab platform. So you can see that the majority, this is the core of the Arapula platform. There's some thickening of the sediments to the west-northwest, and then another thickening along the Akimega. Next. Overall, as you can see, this is the just an example of the time structure map over the area. As you can see, this is the high at the Permo-Triassic level, and it's going deeper toward the Akimega Basin, and also they're going deeper into the west and northwest of the area. Next. So if you look at on the if you're trying to put it in the what is the structural elements, the major structural elements of the study area, then we call this as the Arapura Dome in the middle, and then to the north, this is the Akimega Basin, the foreland basin, and then we also observe the kind of Kola graben in here, Aru Trough further to the west, and going down to the southwest, we identify what we call as a Sindoro embayment, and this is the Abadi High, where the Abadi field is located. It's in here, and then further to the west is the outer arc, outer Banda arc Boltras belt. So this is the structural elements of the study area, if you will. Next. And looking at the stratigraphy, as you see from the seismic section, then this is the oldest horizon that we mapped. It's called the Permo-Triassics. So we didn't map the section below it, but we are focusing on the section to the north, getting younger of the Permo-Triassic. So and this is the horizons that we picked. Is the major sequence boundaries that we mapped, starting from Permo-Triassic, Jurassic, early Jurassic, late Jurassic, and then Cretaceous, and then the Oligocene, Miocene, and this is the youngest one is the Pliocene, the P3, which is the significant boundaries. If you will see later that this is the significantly boundaries in the formation of the Aru Trough. Next. Just to give you the what the stratigraphy looks like. So you saw the seismic section. Now that you see the well correlation. So starting from the south, starting from Troubadour, Abadi, and going to the east, and go to the north toward the Akimega Basin. So you see this is the Troubadour is penetrating the section, and also this is the Permo-Triassic interval here. This is the Abadi number 1. Sorry, this is the Jurassic. It didn't penetrate the Permo-Triassic. This is the Jurassic section. This is the Jurassic section penetrated in Abadi 1, and then this is you don't see much of the Jurassic and the Sindoro 1, and then Mutiara Putih is the well that penetrating most of the section older than the Permo-Triassic. So the wiggles lines here representing the old Permo-Triassic, and you start to see up into the Sindoro, but the Abadi and Troubadour did not penetrate the Perma-Triassic. So again, this is the whole section that you can see the thickening of the section above the Perma-Triassic, then thins out toward the Arafura Dome. And when the section above the Perma-Triassic is quite thin, and then thickening up again toward the east and to the north. Next. This is the section. It's about northwest southeast. Again, starting from the Lainatok, Abadi 1 through Sindoro, Parakan, Toba, Aru, and ASM. Up in here, again, you can see this is the Permo-Triassic intervals that penetrated in several wells, and then this is the Jurassic. Jurassic we see in Abadi and thins out toward the Sindoro. And then this is the Cretaceous interval, which is primarily the fine grain sediments that penetrate, deposited during the transgressions above the Jurassic that cover most of the area, but some it's only covering is very relatively thin intervals in the Aruan and also in the Merpati. And the dark blue color here is this is the myosin carbonate. Myosin carbonate that become the primary target for the Bobara block later on. Yeah. Next, this is probably from this well correlation you can see that how the complex the area at the north side of the study area is quite complex and dynamic. Structurally is quite dynamic, where the wells is on the being penetrated also at various depths. As you can see, this is the same thickness, but then if you compare between what you penetrated in one well, such as in the myosin carbonate, and here you only penetrating a very little or very thin. Okay. Again, this is the structural cross section, so you can see that the up and down of the well positions because due to the tectonic variety. Next. Why that this area is important? I'll go a little bit on the history of the exploration of the area. Next. So, if you look at on the this is the hydrocarbon indication. Yeah, hydrocarbon indication around the area, which primarily focusing along the margin of the shelf of the Australian continent in here. There's a lot of the hydrocarbon indication, which is the observed in as oil seeps, gas seeps, and also the been indicated on the seabed through the piston cores and so on. That it shows you this is a kind of a very prolific area where the petroleum system is there. You can see almost everywhere along here that there is an indication of the hydrocarbon. Yeah, either piston drop cores or the seeps, and also some oil shows from previous wells. Next. In terms of the discoveries that has been made, you see this is the Bonaparte area. So again, this is the Australian continent, basically. The dark red here. You can see the discoveries that made in Australian water, Bonaparte, Sunrise Troubadour in here. This is the Abadi fields, and then going to the north, this is a Bintuni fields. Yeah, and then you can see the discovery in Seram. And if you go to the further to the east, and everybody knows that there's a lot of discovery being made in a PNC area. So, the study area is basically sitting about the triangle of the proven fields, and it's not a small field. If you look at the numbers, 8 TCF in Payundan and in Bonaparte, and then the Sunrise Troubadour 11.24 TCF, Abadi Field here, and then Pintudi, and also the big number, it's what 6 billion has been discovered in the PNC area. So it's supposed to be a very interesting area for the hydrocarbon exploration. Next. So therefore, that the exploration in Arafura area has been started even during the 50s. So 50s and then 70s, a lot of wells been drilled by Phillips, and then in the 80s, there's more operators to come and to explore, but has no luck that been made, and then it does not happen until the 2000, where Inpex discovered Babadi Field. So in the 90s, that the ARCO discovered wells in the Pintuni areas, but in the Arafura area, then the most significant discovery is the Masela, the Abadi one and the Masela PSCs. And another key discoveries that have been made is the what we call Pumera, to the north of Wakam, and also the Chikar one. That is not a discovery, but this is an important data set that we need to look at on the Chikar one well drilled in 2013. It shows the some hydrocarbons in the wells in mice and carbons. So it's been long story of the exploration in here, but it's only one significant discovery is made in the other. Next. So if you look at this is the study area. This is just a plot of the activities that have been made. Red color is supposed to be the active exploration blocks. Yeah, but then the some in here is already been drilling this by now. But this is the map of a year or 2 years ago. So then the active block is still in here. This is the Abadi Masela block. This is Yamdena. Babar Selaru already been relinquished, completely relinquished. This is the Aru and West Papua 4 already been completed. And this is Wokam, already completed as well. So leaving this the North Arafura, and this is the Southeast Papua. If you look at on the here is the variety, the block that has been studied, through joint studies. Yeah. Goyang-goyang. Yeah. Waiting if you have any questions. Yes.
I find that there is a page which shows a lot of seismic.
Mhm.
It seems that in this area, the seismic data is very enough, is it right?
It depends. Yeah, it depends because the seismic are various vintages. Yes, been acquired in different years. Yeah, the seismic that been acquired in the mid 70s and early 80s is not that great. Yeah, so but the I displayed all the seismic. Although
That-
actually that the team also has done some classification of three galaxies, poor, fair and good seismic and so on.
Mhm.
So the not every single seismic is displayed on that slide is at a good quality actually.
Okay,
Yeah, but
Uh,
the 3D data is good.
okay. Let us say from that page, you have put all the history seismic data there,
Yes.
but some the quality is not
Yes.
enough to.
Yeah.
Okay.
Yeah.
Okay.
And
Yeah.
sometimes that even for the structural interpretation, it's only good for structural interpretation, but it's not easy to for tracing the same horizons. Especially if you go in a more detail within the some sedimentary intervals.
Okay. My second question is, there are 5 area, right?
Mhm.
Section 1, 2, 3, 4, 5.
Yes.
So currently, there one, you let us say, how many area are open, or are all the 5 area open now?
Very much open. Very
Much
much open. And only several blocks that currently active, such as the Mastela, where Abadi field is active. And then to the north is the which is located in sector 1. Yeah. And then to the north is the Yamdena block. And then to the north, further to the north on the land area is the only 2 blocks that are active. So actually very much is available. Yeah.
Okay. Yeah. Thank you.
Thank you. All right, while waiting, if you have another questions to be asked to Pak Suryo, you may ask.
While discussing about waiting for this, maybe can you explain about the data availability in the market? Of course, we have MDR, but I understand there is some more data available in the market.
So
I think
yeah.
CGG, I think it's available.
Yeah. So most of data that we got, that I showed you on the slide, is available in the MDR. The only things that has not completely available in MDR is the called Terpang 3D, which is located in the in a Bobara block. Yeah, it's only a portion of it is available in the MDR. So that the we need to work out with MIGAS or SKK MIGAS to get the data, the completeness of the data. But the rest of the 2D data are actually available in MDR. The another data that is also available, but it's not accessible for us, is the 3D data toward the Timor area, which is actually there is a multi-client data 3D acquired by PGS in 2019, if I'm not mistaken. So because it is still under the marketing right of the PGS, so it was not available to us. So we didn't use that 3D, the multi-client 3D in the in sector 1, which is close to the boundary of between Indonesia and Timor-Leste. But the rest is available in the MDR.
So when is the Terpang 3D will be available in MDR then?
Should have been, because the block already been relinquished, right? So you know, we didn't get that Terpang 3D because it was still active under the West Papua Core operated by Repsol, so we didn't get the complete data from them. So now the block has already been relinquished. It's supposed to be that all data being returned to the government. Maybe it's not available in the Pushdatin yet. So we need to get help from the SKK Migas or Migas to get the data.
Okay, thank you. So it's
Yeah.
already officially 100% in MDR. Thank you.
Yeah, but I'm not sure if it is the whole thing.
So
I'm
that's not
if it is the
100%
whole thing. Yeah. So the Terpang 3D survey is over 4,000 square kilometers. But what we were able to access through Pushdatin is only about 2,000 square kilometers. So this is something that you need to check. All right, so let's move on. So again, that the if you look at on the blocks. So back to your question, Dr. Chin. Currently active is this block, that block, and then the this block, the two pieces, North Arafura, and this one, and the rest are already been relinquished. Even the red color in here has already been relinquished. So majority of the area is actually available. Okay, so if you look at again, you know, on the map here, as you see that the most of exploration activities been focused along the shelf, and also, you know, along the Akimaga, the shelf, the northern shelf of the Australian continent, which called now is the Akimaga area. And yesterday, Professor Mino has given the presentation around the area here. Maybe you are more familiar with the terminology of Warim area. We have Warim area is sitting in here. This is the old Warim block, was operated by ConocoPhillips here, but now it's open. And then 2 blocks, Akimagah 1 and Akimagah 2, is located around this area. Okay, next. So what is the plug concept that the in this area that become the basis for exploration next? So this is just a very simple summary of the proven exploration play in this area. Number one, starting from the youngest one, we call as the Miocene carbonate oil play. This is here. This is the Miocene one, which is become the play for the Bobara block. Yeah, Bobara block play would be in the Miocene carbonates. Second one is the Miocene plastic gas play. This is where Abadi field is discovered. It's in the Jurassic and the Jurassic sandstone in here. So this is the second play. And then the third play is the Permo-Triassic, older than Permo-Triassic. So this is the Ordovician, the plastics that was the also the Permian, the sands that is proven in the Australian continents, but it's not proven in here in this area. The 2 key wells that penetrated the sediment older than Permo-Triassics, Aru number 1 and Merpati Putih, that you have seen before in the on the well cross section, penetrated this section here, and it turns out to be very tight. It's only about the less than 5%. I mean, the average is the in the order of 1 to 3% of rusted. So it's very tight, and this is the reason why that our evaluation is focusing on the section above the Permo-Triassic, and we ruled out the Permo-Triassic play or the Paleozoic play in our evaluation. So we only look at them here and here, and as you see here, this is the sector 1, 2, and 4, and sector 3 and 4 that were the play on the cup. I'll show you on the map next. This is the carbonate play, and we'll talk about this more later. And this is Cikar 1, which is the a good well that we can use as the reference for the further evaluation on the Miocene carbonate play. So this is the section combination between the 2D and 3D data. And then this is just a cartoon that shows you this is the water depth, and here it's around in the section here is around 2,000 to 3,000, and then this is the youngest sediments above the P3, the Pliocene, and this is the Plioplasticine section, and the carbonate is it's colored blue, and this is the section deeper than that. Unfortunately, because this is a very deep and complex area, the data only revealing down to the 6 seconds here, and then it doesn't penetrate or record any data, below 6 or 8 seconds. So this is a very deep. Next. So in the I showed you the carbonate play and now the clastic play, and this is a section of the clastic play, which is the span from the Jurassic. This is the purple color here is the Permo-Triassic, and so this is the Jurassic, and then Cretaceous, and also the Paleocene basin floor fan. See in here. So, but this is not in the Bobara block. This is in the sector 1 and 2, so that where the plastic plate is sitting. Next. So this is the just a cartoon to show you the Paleocene basin floor fan. This is the Again, this is the Permo-Triassic, older than the Permo-Triassic, colored in purple. And above it is the clastic sand of the Jurassic, early Jurassic, mid Jurassic sands, which pins out there toward the Arafura platform. And then this is the transgressive of the Cretaceous shales, become the regional seal for the older Jurassic. And then above that, you can see there is a kind of the Paleocene, what we call as the Paleocene. We don't know the age yet, but we constrained by the late Trias, the late Cretaceous horizon here, and also the Oligocene horizon there. So we assign this as we estimate that the time is the Paleocene, which is equivalent with the what we saw in Juni. There is a Paleocene diet. So we believe that this is when the deposition of this interval here. And then this is just to give you a kind of a small cartoon of the distribution of the basin floor fan in this area. Abadi is in here. This is Abadi. This is where the basin floor fan is located. So this the clastic plate, and then the next one is the next slide. And this is to show you where the Jurassic plate, basically where it's sitting. So this is a section from south to the north, starting from Troubadour, just to the north, and this is the accretionary prism there. And then see that this is the Permo-Triassic horizon is in purple, and you can see that Troubadour is penetrating Jurassic reservoirs. Here is proven, and then going down to the north before they reach the subduction of the collision area. Then this is where the opportunity is sitting along the structural track in the area. So those are the place, starting from the carbonate, the Miocene carbonate, and then go to Paleocene basin floor fan, and go to the deeper Jurassic plate. So if you look at on the map next, this is another one. What I called I mentioned before around Sindoro embayment. The Sindoro embayment is the embayment with if you look at on the collision trend is about the east-west in here, and then turns into the southwest northeast. So there is a kind of an embayment in here, and this is the where the Abadi field is located. Sindoro one is trying to chase the stratigraphic trap of the thinning out. This is Sindoro. It thins out of the Jurassic sand, but this is a trap failures. So there is no indication of hydrocarbon being seen in Sindoro. And this is the Abadi well sitting in the Abadi high. And the area here, which is the bonding faults that separated the Abadi high here, that the creating is kind of a thickening area along the embayment here. And we believe that the sediment here, in particular the Paleocene basin floor fan, which is sitting in this interval here, has been supplied from the Goulburn graben or Calder graben to the south. Yes, deposited there, and a lot of the opportunity that the in mapping detail of there, that seems that there is a potential trap. Apologies that this is actually a cartoon, no, because it's not grouped, and it's mislocated. You see that there is a kind of a trap here. It actually was aimed to show you the potential structure stratigraphic trap has been dislocated. So if you look at on here, this is the key of the opportunity here is the prograding sand up from the high, and then this is the bounding fault, which is trend about the northwest southeast here, and been reactivated due to the collision with the Eurasian plate, then creating a series of the strike slip system along this one here that could create a kind of a combination of the structural and stratigraphic trap in this area in the area called Sindoro embayment. Next. So on the map, yeah, you can see this is the Arafura Dome is basically nothing. Yeah, you can be ruled out the opportunity, exploration opportunity in this area. So the prospective area is basically sitting along the shelf, northwest, southwest, northeast, and also along the Akimaka basin. And then the number one is the mycin carbonate. We see in general, this is the trend where the carbonate play that they may work. Number two, the Palicin turbidite basin floor fan is in the area that I showed you before. This is the Abadi field, and this is the embayment. The Sindoro embayment is just only focused around this area here. And then the number three is the Cretaceous play. During the transgressive and also the short we call it the drop of the sea level and so on, that it may created some wedges of the stratigraphic wedges in a Jurassic section. And the number four here is where you can find the Jurassic plate. However, that in this area here, Jurassic may be very, very deep in the Aru Trough. But toward along the high of the accretionary prism, you may still find some Jurassic. Of course, that in terms of the complexity, structural complexity, this is very complex. But then it becomes less complex along this area. Next. So what is the potential of the sector 3? Sector 3 is where the Bobara block is located. Next. So again, this is the area that we're trying to look at. It's around the Aru Trough, the deep water here, where there is a Trepang 3D, there is a West Papua 4 3D, and there's also a little of the Wokam 3D that is available, and with some 2D data. Next. This is the post-drill analysis of the wells, all the wells here, and then been color coded. So the circle with the what do you call it? It's supposed to be orange. Orange color is well that targeting or TD in the tertiary, and the green color is TD in Mesozoic, and well that has the circle in a purple color is TD in Paleozoic. So you can identify, like say the one in here is 3D in the Mesozoic, and then the well it's like in the Merah Mutiara Putih here is TD in Paleozoic, and these are mostly the wells in here are 3D and tertiary because those wells are chasing for the mycin carbonate as the exploration target. Next. So what is the play of the for the Bobara block, which is the mycin carbonates? I think that we should go next rather than starting from here. So this is the GDE that we try to generate. Yeah, the GDE from this well that been generated, it's trying to discriminate between the carbonate outer shelf deep marine carbonate platform and the carbonate inner shell or inner transition. So 3 different colors that we see in here. But Bobara block is sitting there, which is primarily sitting in the carbonate platform. So what you will see is this is the carbonate, and then green, it has been the porosity has been enhanced because of the exposures of this here during the late Miocene or early Pliocene time. So this is the well controls where the Miocene age of rocks that have been penetrated, just shown here as an example. Next. And here is where the Aru trough is. So our concept is actually that this is the reservoirs in a blue color, and where's the source rock? The source rock is the Pliocene. So this is the classified equivalent source rock, which is being proven to be the source for the fields in the Salawati basins up in here. So we are taking the analog of here, and then put the Pliocenes of the source rock, which is being subjected into depth. That making this source rock is mature to generate hydrocarbon. And the 2 key wells as we use as a reference is a Chikar number 1 in here, and then where is Bobara? Bobara is somewhere in here. It's not far from there, but Bobara is sitting further to the land. And then if you look at on the previous slide, see the previous slide, one more click, yeah. So this is the Aru trough, Aru Island in here. This is Aru trough, 3D data in there, and so what this is representing the bathymetry as the depth of there. But basically, this is the distribution of the source rocks, which is over this area here. And if we use that the analog to the Salawati basin in here, Salawati basin is primarily oil fields, oil profits. We use that this is the type of the source rock that you may find in here. And this is the pristine fitting distribution there. So it is an it's a very young, relatively young source rock potentials that have been subjected to the in the area during the last 5 million years ago. Next. So this is the can you go back? Yeah, yang tadi. Next. Here we go. So the way we think that the concept that we developed is this is previously is a restricted low. So this is that restricted low was formed during the proto Aru trough, if you will. Yeah. So the proto Aru trough is actually the extension that has been the fault blocks that was generated during the extension of the late Miocene there. So this is the colored blue is the carbonates, and then if you see that the carbonates, the horizon on the top of the carbonates is on there. That would suggest that it was exposed before the deposition of here, but then there's always a very rapid of the deposition of the young sediments above the Pliocene, the 3 million years ago. And what we think is during that the development of the fault blocks here, this is the area where the restricted lows was generated. And here This is the onlap of the concentrations of the sediments just above it that being restricted in the lows areas here. So potentially, this is the if you look at on during the if you consider the to the north is the collision between the Pacific plate and the Australian continent. So this is uplifted and become the source of sediment. It goes to here, but the some of the area here may be under the influence of marine. So the area here could be a kind of a mix between the marine and terrestrial area. Yeah. So this is the lows where we think that the could be with the high TOC concentration within that low itself. So why do we think that way? Next. I'll show you. This is the two reference. The two reference here is Cikar number 1 and Bobara number 1. Yeah, Bobara number 1 is actually a gas discovery. However, this is the in Bobara number 1 is, hang on, I think it's located somewhere in here. It's not somehow it's not plotted that map. So this is a discovery, a gas discovery with the DST test, but then the it contains a high CO2. This is containing high CO2 in here. So say it was deemed as a gas discovery, non-commercial gas discovery because of the high CO2. It's in here, yeah. So it was drilled 2007 by KNOC. I'll show you later. And this is a Cikar 1. Cikar 1 that has been drilled and penetrated here. Both wells, they experience a technical difficulties during drilling. So lots of the problem during drillings that they didn't expect. But then therefore that the well did not penetrate it or did not achieve the target, original target of the well itself. Yeah. But again, this is the two key wells next. So this is Bobara number 1. So it's penetrated. This is the top of reef, and this penetrated the reservoirs. Yeah. So it reached TD. It's about 3,000 meters. PNA as a non-commercial. It contains over 60% of the CO2. However, that the C1 to C5 was detected, and it tested gas in a TSD. Through TSD there. Yeah. So this is where the reference that we made is in the Bobara number 1. Next. And number 2 is Cikar. Cikar was drilled in 2013. So this is it didn't penetrate the target, fully penetrate the target. It only penetrated the top portion of the reservoirs. You can see that this is the shows of the so this is the resistivity, rho P, and then this is the petrophysical analysis that indicates of the increasing gas penetration, gaseous along the penetrations, and that it shows that the hydrocarbon is there. Yeah, so it does penetrating the hydrocarbon, and then but it did successfully completed the well as planned. So if we look at again on the why that we got the hydrocarbons in here and in Cikar 1 and also in the Bobara 1. Yeah. So that's there is some scenarios that the closest source rock that may support or may source or charge the the reservoirs is coming from the section of the interval here. Yeah. So this is not the perfect area for identifying the source rock at the Cikar-1 location because the low itself is sitting to the south of the well. So we in our analysis we suggest that the intervals, the Pliocene intervals, contain high organic content and then been subjected in a depth. So in the previous slide before, lagi, next, yeah. So in our basin modeling, this is just a quick, simple basin modeling. So it suggests that with that depth and temperatures that been, experienced within this interval here, it seems that it's already generating the hydrocarbon to fill in the this is Cikar and this is the Bobara is up in here. So that's what we think, that it is the closest source rock that could charge the Miocene carbonates. The older source rock, the potentials, because it is very deep, may already become kind of a dry gas, which is may not filled in this area, but it's been migrated out of the Aru Trough. So these are, if you see that in our modeling we put all the leads been mapped in here, and seems that it has the capacity to charge all of the leads that been mapped and identified based on existing data. Next. So this is just an example of the section of the leads that we mapped. Bobara area is, I believe, that somewhere in here. Yeah. So because we when we did this evaluation, we don't know the boundary of the Bobara area yet. So Bobara area, I believe that Bobara area is somewhere in here. If you plot it, and this is the two lines, just to give you ideas. Line number 1 in here go through Cikar, be projected in this one. So this is the top of the reservoir. This is top of the reservoir is over here, the top of the carbonates. This is the base of carbonates, and we believe that the source rock was deposited up in here. This is what we call this the restricted low areas before the deposition of the mass transport complex. During the optimum development of the Aru Trough. And this is line number 2 that goes across these leads in here. This is the leads I, this is the leads D. Again, this is the top of carbonate in here. Yeah, and then this is the P3 that just to separate between the mass transport complex and the youngest sediments entering the Aru Trough from the section below. Next. So this is the leads that have been mapped, a combination of between 2D and 3D. So there are 10 leads that have been identified. Again, this is the section A to A prime goes to here. So this is the deepest part is represented by this green area, and this is the leads of lead D in here, and then this is the lead of the starting from here to there. Yeah, you can see that the most or the fault bonded leads at the Miocene carbonates, and this is the lead the line B to B prime, starting from the big one that we identified in here. This is this is the water depth, and this is the interval above it. And above the green is this is the mass transport complex that we believe also. So the source rock could act also as the seal for the Miocene carbonate itself. Next, we did some CRS and CCRS around here. So this is the reservoir CRS. Basically, it's green, but then on the reservoir quality, we believe that along the low area here is quality is less. Seal maybe only in this area that because it is exposed, and this is the source rock primarily in this area here. This is the high. There is no source effectiveness, and if we combine between presence and effectiveness, then we got the three colors. So if we put on the prospectivity or lead maps next, then actually our leads is sitting in the yellow color. It's only few leads that sitting in the red color. This one here, which is sitting in a very deep location. So this is the leads, and these are the water depth. So water depth is between 900 to 1800. The deepest one, the 3000 and so on. We think this is the kind of a red color. And this is the resources that the potential recoverable resource that may been contained within the of each of the leads. Next. That's it. Any questions?
Thank you, Pak Suryo, for your presentation. Okay, ladies and gentlemen, if you have any questions, you may raise your hand, mention your name and what institution where you're from. Okay, go ahead.
Thank you, Pak Suryo, for the very nice presentation. I'm Buddy from Conrad. I have two questions, two simple questions. So the first one is, if we look at Bumrah well, so they have DST and they have gas there, but the CO2 content is very high. Do high CO2 content can be detected in other wells in the surrounding areas? That's the first one. And second one is, so we have a lot of 2D and 3D data there. The 3D data covering tens of thousands of kilometers, if I'm not mistaken. So why did the previous operators relinquish the area? What did they, potentially did not see maybe back then? Thank you.
So number one on the Bumrah, this is the Bumrah is the anomaly. That the only in that well that they contain very high CO2. The further investigation with the data and so on, it suggests that there is a combination between the CO2 coming from the carbonate itself, but also because if you look at that, it located close to the Herrera-Iduna fault, major fault, there is some contribution from the mantle source. Yeah, so that that could be the why only Bumrah that has the very high CO2. We don't see high CO2 on the other wells. And number two, that it does covered by the at least around maybe around 6,000, 7,000 square kilometers 3D data. It depends on the strategy of the company itself. Yeah. So if you look at on the previous operators, West Papua 4 was operated by a certain company and then transferred to other company and then transferred to other company again and so on, and different company has a different strategy. So therefore that the maybe number one strategy doesn't fit with the deep water, carbonate reservoirs, and then number two is the number three maybe that it's remote. So it seems that the development could be a challenge. However, that we did some exercise in terms of the developability. It could be developed, but it has to be in a good terms. And when we already, suggested to the government to give good terms, otherwise it would not be able to be commercially developed because it is cheap, and also that the resource or the productivity itself could be a challenge. So again, that it depends on the operatorship, the operator itself, and also the fiscal terms that been offered by the government.
Okay, thank you. Is there another question to Pak? Oke, berikutnya ya Pak.
On. It's not on yet.
Pak Suryo, my name is Andi Mardianza. I'm from Pertamina Hulu Energi. In this area, Bobara offshore Aru, it seems that the migration mechanism predominantly lateral migrations. So how about the quality of the carrier bedrock in this area? Yeah, to become oil and gas can migrate easily from kitchen to the reservoir. And how about the behavior of fault in this area? So if the fault is leaking, is so as to prevent hydrocarbon migration, and if more sealing, so the oil and gas can migrate to surface. So how about the fault? Maybe it seems faults can be erased in this area.
Yeah.
Thank you very much.
Thank you, Buddy. So the migration is very short distance, because if you can you go back to the slides? Yang ujung belakang. Naik. Atas. Atas. Yeah, thumbs up. Yeah. So if you look at on here, just to give you an illustration, so that you have the leads in here, you get the kitchen next to it. Yeah, you get next to each other, which is it doesn't need to travel long way. Yeah, and secondly, if you look at on the structural trends here, it's trending that way. Yeah, it's trending in one way. So the migration could goes from this nose here or that nose there, entering to the leads or to the traps. So we suppose we assume that this is a kind of a seal, a trapping mechanism, because it is to the top, if the faults doesn't intersect the mass transport complex. Yeah, so it is covered completely by mass transport complex, and then we assume that this is kind of a sealing fault that could define the trap itself. Does it help, Party?
So if we assume that the near kitchen has attractive maturity, so so that we can get the short distance migration. So based on your explanation before, we need to find the low structure to get the more kitchen area more mature. So we need to go certain part to get the deeper area as a kitchen.
Yeah. So the
Or
The maturity is basically also controlled by what you call it, the seabed, because the temperature, it does not reach the temperatures along with the seabed here. So it's not necessarily to be concentrated in here, but it's also distributed over this area as well.
Alright, Pak.
Yeah.
Thank you, Pak Suryo.
Okay, next question, please.
Hello, sorry, my name is Chin from Sinopec. My first question is about the source kitchen. I remember you have mentioned the analog of the source kitchen by Salawati, right?
Yes. Salawati.
As well, in the south, there's a gas field, a giant gas field, Abadi.
Mm.
So I remember also there's one slice in the south, the source kitchen is nearby the trough, right?
Mm.
Nearby the trough. As well, in this area, also we have trough. Can we understand the source kitchen will distribute along the trough from the south to the north?
So actually we are looking at the different stratigraphic. Yeah, different stratigraphic. Itu ke atas. Enggak, yang di atasnya. Ke bawah lagi. So for Abadi field, we are looking at the interval down in here. Yeah. So this is what we call as a Jurassic. In the Bobara area, we are looking at the interval up in here, which is in the carbonates. Yeah. So the assumption for yes, you're right, that the kitchen may be developed somewhere here, which is migrated up to fill in the Abadi field and so on. Or there is also Calder Graben that they have been responsible for the maturity of the source rock to charge the Abadi field. This is not the Abadi field, but this is equivalent to the Abadi field, if you will. And then for the so the how do I coba ke atas, Mas, to make it easier for you to understand the setting. Next, ke atas lagi. Okay, yang tadi. So Abadi field is located in here, and stratigraphically it's much older, right? And we believe that the Abadi field has been charted by what we call as the Calder Graben, and also some contribution from the north. They migrated to here. While in here, it's actually the kitchen is within the trough itself. So it doesn't come from potential kitchen along the collision or underneath the accretionary prism. But for the Aru trough, we believe that the kitchen is inside of the Aru trough. So the migration is within the trough itself. Yeah. So it's a different of the migration story between Abadi and the Bobara block.
Is there any analog about the kitchen source between the Aru area and the Tanggu area?
Yeah.
Because
So
it's nearby, right?
Yeah, the nearby is the Salawati up in here. So that in terms of the charge of the source rock is about the same age of this, yeah, and it's charged of the fields in here at the carbonates, the same age carbonates reservoir. Yeah, so it's proven over 300 million of the oil has been discovered in here. Yeah. So this is this is the closest area that we can take as the analog for this one here, which is look at it, it's not too far from the Bobara block.
Okay. Thank you. My next question is, from the last slide, so we can see this area is a high risk or very high risk area. But from the announcement, the block, it seems the split, high risk and very high risk. The oil split is, for example, the high risk is 16, 14. For the gas is 55, 45. I remember for the Argon, the split for the contractors is around 18%, 80.
80
So
for contractors.
yeah. So I want to know for the first page,
Yeah.
is after tax or pre-tax?
I think this is pre-tax.
Oh, this
Sorry, post-tax.
Oh, it's
After
post-tax.
After
Okay.
tax. Yeah.
Okay.
Yeah.
I got it. Yeah.
So if you break down, correct me if I'm wrong. If you break down, then the pre-tax may be in the order of 70-30 or something.
Okay. Yeah.
So 70% for contractors and 30% for government. Yeah. I think it's around that number. Yeah. But then because it is you put tax in it, and then so it's lumped together with between the entitlement of the government and tax. Therefore, that the government will get a bigger portion.
Okay.
Yeah.
So that to say, for this area, the risk is less than the Argon, right?
It's different play.
Different. Okay.
It's a different play, different geology. The risk, but just to give you the a comparison, I think it's about similar.
Similar.
Yeah, it's a similar risk. Yeah, but then the question is again, and I don't want to comment anything about Agung.
Okay. Yeah.
But then again that this is the young age source rock, right? But in our model, it suggests it is mature. In Agung, it is an older source rock. Yeah. So so it's different age of the geologic system that we are looking at between here and Agung.
Okay.
Yeah.
Yeah. Thank you for your answer.
Thank you.
Yeah, for more information, Pak, this Bobara is we valued this block with the same risk with the Agung. It's same we give this a very high risk split. Yeah. So for the gas you will get 50-50 for the after tax, and for the oil is 55-45. So Agung also 45-55 and after 50-50. So this is the same very high risk level for the offering.
What is the split before tax?
Perhaps Pak Adian, for the tax is about 37.6. So I think for the pre-tax for the gas, it can be 80%, I think.
80-20.
Yeah.
Okay. So 80-20 at the favor of contractors. Yeah. That's.
Pardon? Yes. Yes,
Yeah,
around that,
yeah.
yes.
I
And-
believe so in that kind of a bulk number.
Yes. And
Uh,
for the
ballpark.
post tax is 50-50 for the gas.
Oke, thank you. Pak Surya, ada pertanyaan di online. Coba kita baca bersama. Dari Pak Hitler, dari PHE, on the fairway map, page 27, why is this basin floor plan play only in the area number 2? Can you explain it more clearly? Okay, please,
Yeah.
Pak Surya.
Well, actually, my presentation today is more focused on Bobara, so I didn't really give the presentation and the sector 2 on the basin floor plan. So my presentation today is focused here for the Bobara area. Yeah.
Okay, thank you, Pak Suryo. Okay, is anyone have another question to Pak Suryo? Siapa lagi di online? Nggak.
Online ada lagi? Nggak ada. All right. Thank you very much. Thank you for your attention. Hopefully it helps. And it is it's a rare opportunity to see the area in here, but the key wells, Cikarwan and Bumerawan, could be a hint to be used as the reference for exploring this area. You can do your evaluation in a more details with the existing data that is available. Hopefully that the 3D data is complete and it's available in a full set, which it wasn't at the full set when we did the evaluation here. All right, thank you very much, everyone. Thank you.
Okay, thank you, Pak Suryo. Before closing, Mr. Hotma would like to add some information.
Okay, thank
Please.
you, Pak Farhan. From the government side, we would like to appreciate for the ministerial team for the team 9. We can see, I think most of the member of the team 9 already present here. We have Pak Suryo, Pak Herman Darman, Pak Lili, Pak Alit, Pak Sony, and also Prof. Mino. Thank you for attend for this business forum. Yeah, already said before that Bobara is come from 2 blocks, previously known as Aru and also West Papua 4. And both of this block terminated just end of this July. So all the data is on the catalog listing process in the SKK Migas. And for the data project and also the report from the resulted of the evaluation conducted by the ministerial team already delivered to the Pusdatin, and we will provide all the data in this bidding ground. For the 3D Trepang, we get information from the Pusdatin. We already provide this 3D data with the size around 3,900 kilometers square. We provide this all data in the data package, and data package is free for the non-member of MDR. For the member of MDR, we provide with no limitation data. So all the data that already result from the Repsol activities previous contractors, we will provide to support all the evaluation conducted by the investor who wants to invest in this area. So the duration of the bidding round is about 2 months. We provide the attractive fiscal terms with no minimum signature bonus. And also we provide the very high risk split. I already said before that for the oil, we will give 50-45, 55-45, and for the gas, 50-50. So we would like to invite all the investors that attending this meeting to evaluate this area and to submit on the end of the date of the bidding process. And if you have any questions for the further information, you can contact us for the email and also for the telephone number that already we stated in the booklet. So for the closing, for one more time, we want to say thank you for Pak Suryo to deliver this presentation. We hope that this area become an active area again, and we can support for the 1 million barrel oil per day as our national target for the oil productions. Thank you for your attention and keep healthy, and see you in the next bidding round. Thank you.